Hi! In this video, I have elaborately discussed the method to find extrema points for parametrically defined curves without having the need to convert them into Cartesian form. We shall understand this method step by step through a question. Step number 1. Find dy by dx using this formula. Step number 2. Find the critical points. Critical points would be the points where dy by dx either becomes 0 or undefined. In our case, such points will be t equal to -2, -1, 3 by 2 and 2. Now, since the interval of analysis is only between -2 and 2, not including -2 and 2 themselves, we will only restrict our critical points to t equal to -1 and 3 by 2. Now comes the most important step, step number 3. This step can be accomplished using two ways. First way, using the wavy curve sign scheme for dy by dx. Now, make a number line and mark the critical points and assign sign to these intervals using the wavy curve sign scheme that you have already learned earlier. Now, looking at this, you may think that the curve has a local minima occurring at t equal to -1, which actually corresponds to x equal to 31, and a local maxima at t equal to 3 by 2, which corresponds to x equal to -32.28. But let me give you a shock. This is a wrong interpretation. As you can see from the graph of the curve itself, the curve is actually suggesting the other way around. So where did we go wrong? Isn't this the same thing that we used to solve other problems as well? Well, let me explain. For knowing the nature of the extrema points, we study the sign change of dy by dx as we move along x-axis from left to right, not as we move along the t-axis. So what mistake we were doing? We are trying to see the sign change of dy by dx as we move along the t-axis. So let me show you the correct picture. So when you convert this number line in terms of x as shown here, you will realize that at x equal to -32.28, which corresponds to t equal to 3 by 2, there is a point of local minima. And at x equal to 31, which corresponds to t equal to -1, there is a point of local maxima. Now, let me tell you the second way, which is using the double derivative test. But before I start this test, let me tell you that this test has a drawback. It only works for such cases where d2y by dx square exists. That means where dy by dx is defined. So I can only use for critical points where the numerator f dash t is 0, but denominator g dash t should not be 0. Thankfully, in our case, t equal to -1 and 3 by 2 both makes f dash t only as 0, but they do not make g dash t as 0. Now, we all know d2y by dx square for a parametrically defined curve is as shown here. Now, using f dash t equal to 0, we can further simplify this expression to this. Now, here you would realize that the sign of d2y by dx square is same as the sign of d2y by dt square, and d2y by dt square is very easy to calculate. So, as per the question, dy by dt is this, d2y by dt square is this, and when you put t equal to -1 in this, we get a negative answer. That means at t equal to -1, there is a local maxima. And when you put t as 3 by 2, we get a positive answer, which means at 3 by 2, the curve has a local minima. So friends, I hope this video was helpful to understand the location of local extrema for parametrically defined curves.